Okay, welcome back. In the previous video, we deployed our CRUD MEAN stack application manually, right? In this video, I'll show you how to deploy the same application using Docker, so which makes deployment much easier and faster. So today, by the end, you will understand how Docker simplifies deployment, packaging, everything our app needs into portable containers. So first, the Docker. Docker is a containerizer platform and it allows us to package our application along with all its dependencies. So if we want to dive into the Docker, we have another separate session for the Docker. So just go through that. So now we'll break down the min stack components according to Docker. So our application has three main parts, right? Backend, Node.js plus Express API, and front end, Angular build files served by a lightweight server like Nginx. We already did in the last class. So the database we use MongoDB, right? Now we'll create Docker images for each component. That means backend one image, front end one image, database one image. In the previous class we have seen with the image we created database within seconds, right? Now today also we will build image for the backend and front end, and we will create a containers for front end and backend. Okay, now so here in this project, for the database we don't need to write a Docker file. So basically if you want to create a container, we need a Docker file, right? So but for the database we don't need to write a Docker file. We can simply using the official Mongo image, right? Okay, now we'll start the deployment using Docker. So same like the previous session, we need to create a server with 2 CPU, 16 GB RAM, and we need to open the ports for internet 80, SSH 22, backend 8080, and DB 27017. Right? Let's do that. Okay, I open Azure and creating virtual machine. What I did in the last class, I'm doing the same thing. So okay, let us see the architecture diagram. In the machine, in the virtual machine, we'll install Docker, right? The first step. In top of Docker host, we'll create containers. How many containers will create? 3. DB, backend, and frontend. So one more component is Docker Hub. So in Docker, we'll mostly use the commands docker run, right? And Docker file. So if you want to create a container, we need a image. So for that image, we need to write a Docker file, right? So this is the workspace we are using in our machine. So like a directory. So we have two directories, backend and front end, right? So each one we should write a Docker file, because backend we need a image, front end we need a image. For that purpose, we will write two Docker files in backend location 1, front end location 1. So after writing the Docker file, we'll build, right? If we build the Docker file, we'll get a image. So backend one image will get, and front end one image will get. Those are called custom images. Okay, that is completely given the instruction by ours. So but DB is official image. You'll get it from the Docker Hub, right? Okay, in the backend we'll write front end will write. So the backend code and front end code will be in the Docker file. Once build the Docker file, it will go for the, once we click build, it will go for the Docker file and it will create a image, right? So once we will run the docker run command, it will search for the image. Okay, once it search for the local, if it is not there, it will go to the Docker hub and it creates a DB and another run. So but now we have a local image for backend and front end. It will take that image and it will create the two containers, backend and front end. Okay, and then we established the connections. We know IPs and URLs. Then our application is on live, so we can access from the internet. So while connecting with the internet, it will connect to the machine first. So from there it will connect to the container. Okay, let me draw like this. First it will connect to the machine and to the Docker container. So that is why while exposing our application into internet, we need to give the two ports. One is container port and host port. The host port and container port. Here we need to give container port and host port are 8080 for application for backend, both 8080 for DB 27017. Okay. Now the request will come from the Docker host to the containers. Now we'll start creating our server. So creating virtual machine, these things and all we done already. So once the deployment is completed, we need to allow the port numbers. Okay, let's see. Oh, so once it's done, we need to connect to our server, right? See, actually the command is to connect from the git bash. So if we have the public key, basically we are using while working with the AWS, but now we are using Azure, right? We can log in with the user ID and password. You must aware how to log in from the git bash also. Okay, now I'm moving to the sudo user, sudo su. Now updating apt update. See, after updating we need to install Docker, because all the three containers we are creating by using Docker only. So that's why I'm copying. Simply if we paste here, we'll get a file. .sh file means a shell script. So we already did the last class. sh file name, then it will execute. See, for the DB purpose, we now need to create a custom image. With the official image, we'll create a MongoDB. So here, this is the command. We already did the same command in the previous class also. So name, my Mongo, and root, password, everything. Okay, completed. Let's check the Docker version. Docker-fn version. We are using 28.4.0 version. Now check, is there any images? No. Docker images and Docker ps. There is another commands to do this. Those Docker image ls, Docker container ls. So there is no difference. Okay. Now ls, nothing is there. So now the first thing, we need to start our DB container, right? Let's copy that command and paste. So it's not available. Already told you in the diagram, it's pulling from the hub. Unable to find image locally. So that is why it's pulling the image from the hub. Okay. So don't skip the diagram explanation part. Okay. If you miss that one, go back and see. Right. The container created. Now Docker images. Now we have a new image called Mongo, and Docker ps we have container with that image. So our DB is ready. Okay. So let's take the DB container IP, right? Because we need to mention in the backend for the communication purpose, right? So note down the container IP. So how to see the container IP? The command docker inspect container name or ID. Then we'll see the container IP. Okay. Right. So let us clone the repository to our local. So git clone our URL. Now we have the CRUD directory. So now moving to the CRUD directory, we have two more directory and one readme file, backend and frontend. Now we need to create the Docker files for both. So tree is command to visualize entire directory structure. What are the directories we have? What are the things in the directory? So I install the tree command. So check, yes. See, so clearly now we can see what are there in the each directory. So in the backend directory, the things in the front-end directory, right? These are the things under front-end directory. Now we need to create a Docker file in backend and a Docker file in front-end. Okay. Okay. Now backend and front-end. Now we're moving to the backend part. So we already did the same thing previous class. So where we need to update the config files, in the config directory we have db.config.js. Here we need to update our DB container, right? Container IP. So same thing I'm doing. This is for the communication between the our backend and DB. So I just copying the IP and pasting in the here, right? Okay, WQ, save and quit. Now I need to start our work creating Dockerfile. Okay, VI capital D. So Dockerfile must be the starting D is in capital letter. Okay, so here we need to write the instructions. So what is the first instruction we need to write? See here, actually what is the backend will do? It will take the code and build and server start. That is the backend work we have to do, right? We'll download the node and we'll copy the code and we'll build the code and then we'll start the server. So these things are we need to mention in the Docker file to automate the procedure. So what is the first thing? If you want to do all the things, we need a base image. So what is the base image? Node. I am taking node version 20. Okay, saving that file, and we have only one instruction in our Docker file. So once the instruction given, we need to build the Docker file. It will create a Docker image. Okay, right? I will give a name as snap1 and Dockerfile location. So the build command, what it does, okay, it will go to the Docker file and read the instructions. With that instruction, it will create an image. Okay, let us see. So we have given only one instruction. The image contains only node with the version of 20. Let us see. It's taking time. Okay, finish. Let's check Docker images. Now we have two images. One is official image and the second one is our custom image. So what is there in that image? If you want to see, we need to create a container. First, see, only we have DB container. Now we'll create a container with the custom image. To see what is the instruction we given the instruction, right? Is it working or not? We'll check. Now I created a container, Docker PS. Now the custom container is created. Now I get into the container and see whether the instruction is working or not. To get into the container, what is the command? Docker exec -it container id bash. Now we are in container, right? See, so actually the container is like another machine. So we are under root directory and the user is root. So by default we are under root directory and user root. So the given instruction is install node. Yes, node is installed, right? So that means what are the instructions we are given in the Docker file is working fine. The image is fine. Let us exit and we'll update the next thing. What is the next thing we have to do? See, actually by default it is in which directory? Root directory. So that is not a good practice to work under root directory. So for that purpose we will create a custom directory to work all to do all the work. So for that, what is the command? What is the instruction? Work dir create a directory. So whenever we log into the container, the work will be done in that directory. So we have given another instruction. Once given, then updated the Docker file, we need to build it again. So now I'm giving snap2. okay, and Dockerfile location. Now it's completed. Now it is done very fast because already the node is installed, right? So now check. Yes, second image also there. Now what is the next thing? We need to create a container with that image, snap2, naming container 2. For each change I am creating a container to understand what are the changes are going in that container with the image. Okay, now we have another container, new container. Let's get into the container and we'll check what are the changes. So then only we'll understand what are the instructions we are giving in the Docker file, how it is reflecting into our container. Once you understand, then it is easy to write Docker file for any kind of application. So now see, we are not in root directory. We are in separate backend directory, right? Check. Yes, we are in backend directory. So whatever the work we will do, everything will be done in the backend directory. Okay. I'll exit from the container. See, the next thing is code and build. So we need to do these both things by using Dockerfile. So how to do this, we'll see. So before going to that, we need to copy entire code into the container or only package.json. So what is package.json, we'll see here. So package.json is a configuration file used in Node.js and JavaScript projects, and it contains project details, name, version, description, and dependencies, libraries your project needs, and scripts, npm start and npm test. Those kind of things are under package.json. Okay, so the thing is, so why we only copy that JSON file? Because Docker build images in layers. Okay, by copying package.json first and running npm install, Docker install dependencies only once unless the package.json changes. So this makes rebuilding images much faster. And if you copied the whole source code before installing, even a small code changes would force Docker to rerun npm install, which is slow. So instead, copying only package.json means dependencies are installed only when needed. So this is the recommended approach in the Node.js Docker community. Okay, so it keeps builds clean, modular, and faster. Okay, now we'll get back to our Docker file. Vi Docker file, insert mode. Now I'll copy full code or only package.json. Only package.json. Copy from the host to the container. The first one is host address. So with the name of package, whatever the things are there in the host will be copied into the / means backend folder in container. Okay, now updated. Now after updating, Docker build. Now I will give a name -t. What's that? Snap. Okay, 3. Dockerfile location. Now check Docker images. We have the snap3 image, right? So with that image, we'll create a container name 3 and we'll check that is created or not. No. So let's check container created. So now we'll get into the container and we'll check. Okay, docker exec -it container 3 bash. Now we'll see we have only package.json. Okay, That means our Dockerfile instructions are clear. Right, exit. Now the next thing, once we copied the package.json file successfully, now we need to give npm install, right? So run npm install. So we already discussed in what npm install, right? So docker build -t, now snap 4 Dockerfile location. So for each instruction, I'm building a new image. With that, I'm creating a container to understand how the Docker instructions working. Dockerfile instructions, right? Now with the package.json file, we'll get package.log.json. We'll see whether they are working or not. Okay, Docker images. With that imager, we'll create a container now. Docker run -hyphen name container 4 with the image snap 4. Now I should get into the container to check whether the npm install is done or not. So this is from scratch. That is why for each instruction I am doing this. Yes, we got node modules and package log.json file, right? Okay. Next instruction. Once we done the build part, what we need to do? We install the packages and dependencies. We need to start the server. But for starting the server, what is the file we need? See, server.js, right? To start our backend server, we need which file? Server.js file. But check it is there in our container or not. No, in the container only we have package related files only. We don't have server.js. So now the next step, we need to copy our server.js file into our container, right? Let's see how to do that. So okay, server.js in host only, not in container. So now we Dockerfile. Now we'll give the copy from host to container. So in the host, whatever there in that directory, everything will be copied to the current directory. Host means in the host we have all the code, and second dot means in the container. That means whatever there in the host, everything will be copied into the container now. Now we'll check. Wait. So Docker images. Yes, we got the new image. Now we'll create a container with that image. Docker run -dt -name. So we'll create a fifth container with a snap 5. So what are the things? Docker exe, we'll get into the container. We'll see what are the changes happen. For before container, now updated container. So now we got the server.js file, right? With that instruction, even we copied server.js file successfully. So exit from the container. So once it is done, now what is the next thing? We need to expose our application. expose our application in the port number we need to mention. Backend already told you 8080. And while starting the container, what is the command to run? That means we already started container manually in the previous class, right? So once it started, we are not able to do anything in that interface, right? Now we'll do the same thing here, npm start. Now with the Docker, the problem is solved. So once it is updated, now we will check before that whether it is working or not. So I just copied the server.js, but I have not started the server. So that is why no output will come. So nothing. Right. So once updated the Docker file, we need to build. Docker build -t. So this is the final thing, right? Snap 6. Maybe this is the last image. Okay. Docker images. Wait, images. Now docker run -dt -n name. See, if we started the container exposed, but see here port 8080/TCP. That means our application is exposed, our container is exposed. But see the output. Is there any changes? We didn't get anything, right? Nothing. But check with the DB IP 270.1.7. Yes, it looks like you are trying to access MongoDB or HTTP. See the difference here. While creating our container, we didn't give port -p. Right? Now I will stop the container. Port forwarding and port mapping are the most important things in Docker. Okay. We just exposed in Dockerfile, but we didn't give the port. Okay, I'll remove the container. And yes, successfully removed. Docker. I'll remove the image also, because this is the last image, right? I'll rename the image. Okay, Docker build. I'm building the same Docker file again with a new name. That's it, so that you don't get confused. So I'll name it as a backend image. Okay, dot. So now I'll get the image with the name of backend image. So it's completed. Docker images. Now I have the backend image. With that image, I will create a container now. Docker run -dt detach mode -n name. I'll give a name as backend -p. Now I am giving the port numbers. First port, container port, image name, backend image. Okay. Now check. Docker ps. Now see the ports. From all the traffic, it's going to 8080. Now refresh. Yes, it's working. Now check with the DB connection also, /API/tutorials. Yes, it's working. That means our backend server is running, at the same time it's connected to the database. Right, we'll remove the remaining images. Okay, we'll keep only what's the image we need, and we'll remove the remaining image and remaining containers as well. Once we remove the containers, then we can able to delete the images. That is a good practice. Even we can remove forcefully, but not a good practice. First I will stop the containers. This is all about backend, right? The same thing we need to replicate in the front end also. Now I will remove. For understanding purpose, I created those images and containers. Okay. Now all the things are clear. Now Docker PS only two containers are running. One is our backend and one is our DB. The DB and backend. So now Docker images only we have. Okay, many images. I need to remove those images also. Snap 1, 3, 4 and 5. Only I will keep the final image. Okay. Now we have two images and two containers. Right. So we need another image for front end and another container for front end. Then our application is completed. Let us see. Now I am moving to the front end part. So I am changing directory to the front end. Okay. Here also we have package.json file. And what is the first thing we have to do? We need to modify the file, right? So in the readme file we have that address. So it's app services. I'll copy the and I'll paste. Okay, now vi with the vi editor I will edit the file. So now in place of localhost we need to enter the backend IP address. So what is the public IP address? Right, copy and paste. Right. So the connection is established between the front end and back end. Now we need to build the front end server. Now I am creating a new Docker file. Nothing newly I am doing. What are the things I have done with the backend? The same things. Same base image node 20. And what is the next thing? Work directory we have created there. So I am giving here slash front end. That's better. And next one, copying the entire code or only package.json? Only package.json file into our container location. What is the containers? Dot slash means front end. So after copying that, run npm install. Right, what are the things we are done in the backend? The same things we are doing in front end. So after npm install we need to copy the entire code, right? Save and quit. I am building the updated Docker file. -t again with the name of snap1 location of the Docker file. Now I am doing for the front end part. Okay. So I already did in the back end. So that is where I given the 5 instructions at a time. I know what are the changes will come with that instructions. So if you know all the instructions, what are the changes done, then you can write within one time the Docker file. But to understand from the scratch, I made build for each instruction. So let it doing run npm install. Okay. Okay, done. Exporting layers means it's almost finished. Okay, now we'll check the images. Docker images. Now we have the new image called snap1 for the front end. The same thing, now we will create a container with that image and we'll check the changes. Container 1, snap1. Now get into the container. Docker ps, this container created. exit container 1 bash. Okay, Docker mistake. Okay, we are in front end. At the same time, node modules we got, that means npm install run successfully, and node is also there. Only node. Okay, right, everything done. Okay, now we have node modules and the entire code even. Okay, so now if we have the what we need actually to get the code, dist. So for dist, what is the command? We'll update in the Docker file. How we'll get the dist? Once we done the build, then we'll get the dist, right? Now run npm run build. So once the build is done, then we'll get the dist folder, right? And let us see. Docker file updated. Now building the Docker file to get a new image. Snap to location of the Docker file. Okay, it's doing building the code. Last instruction, you can see 6x6. It's exporting to the image, exporting layers. Okay, now check Docker images. You get the new image snap2. I'll create a container with that image. This is the best way to, as a learner, to do with the Docker file. Each instruction we'll need to check whether it is working or not. Is there any errors we are getting? Because once you written all the instructions, we'll get we need to work on more time to solve the errors. Okay, so if you know the manual part, then only you can go with the Docker file, right? So now we got the dish folder. So in the previous class, we understood that where we need to keep this dist folder to get the output. So in the dist folder, what we have, angular-15-crud. In that we have some files. We need to keep those files in the Nginx server, right? Let us see that. These files we need to keep in the Nginx server .html. So for that we need Nginx server. See, so we'll update the Docker file with that command. Sudo apt install Nginx. So I will update the Docker file. So what's the next one? Run apt install Nginx -y. Okay, so here a thing is there and we'll discuss it later. Now, so the last part we have done the same commands, right? Now I'm executing the same things. but we need to do something more. We discuss it later. So we need to remove all the default file in the Nginx. So that is why rm-rf, right? Okay, next we all know that copy the dist folder content into the var www html. Okay, now recursively copy all the things. Now save and quit. Update a docker file. I need to build the docker file. Docker build -t over the snap. Okay, see, we got an error. See, apt install Nginx, why it's not successful? Why? Because whenever we are updating any packages, we need to give update first. So see, before going to update any packages, we need to update our system, update our machine. For that, run apt update. So that is why I wantedly done this, to remember this error. Okay, so while updating any packages, we need to update our machine first. So now let's see. This is one of the important thing to remember. When updating any kind of packages, we need to update our machine first. So after sudo apt update, then only the update app another package will be downloaded, right? Now it's okay. Now check docker images. Yes, we got snap 3. With that image, we will create a container and we will check. Name container 4. Yes, container 3. Snap 3. Right. Docker ps, a new container is created. So everything is fine, right? We copied the things and everything is fine. So no error while building the image. Now see the images, the containers. Now the thing is, once check the docker file, we need to expose our application, right? So now give expose 8080. Now front end, right? 80 is enough. And for that, cmd, we need to start Nginx, right? So we have the cmd instruction from Dockerfile. Nginx is the main web server process we are starting. That is why Nginx and -g. It's a flag. It's pass a global configuration directly in the command line. So or else it go to the Nginx config file. If we give directly, it will do here. What it has to do? Daemon off. We are telling Nginx to run in the background, but instead in the foreground. So this is the cmd command. So without -g, and it will go and search the inside the nginx.configuration file. So that is why we are passing the global variable. And now we'll build the image -t, and we'll keep it as a final image, right? Front end image, right? And the image is building final image. So to understand from the scratch level, I am building every instruction and I am creating a new container to see what are the changes are going to happen in the new container. So while working with that, you no need to do like this. We can write directly. So once you understand the manual setup, then only it is easy to work with the Dockerfile. Okay. Okay, it's almost finished. So you can keep these projects in your resume as a fresher, as an experienced. So now Docker images. So we have the front end image, right? 29 seconds ago it is built. Now let's Docker ps. We got the containers, right? Now Docker run -dt -name will give us front end. Okay, now -p will assign a port 8080 with the image, front end image, right? Good. Now Docker ps container created. Let's see whether it is working or not. Yes, our application is on live. Everything is fine. Title test successful. Submit. Yes, now it is successfully connected to the backend and it is working fine. And I'm giving an entry to check whether multiple entries are there or not. Okay, reading and delete. Everything is working. Data level, database level, everything is fine. Now Docker ps. See, meanwhile we'll remove the remaining containers. Only we'll keep the required containers. Okay, containers removed. Okay, 3 containers are working for our application. In the starting we discussed only we have 3 containers, right? That is done. We need to delete the remaining images also. Snap 1, snap 2. See the command docker rmi to delete image, docker images. Okay, docker images, we have 3 images. And Docker ps. See, but the once observe the size of the image 1.57 GB. So this is a not good practice to maintain such a big memory images. So image should be less and it should be portable. Okay, cd backend. Now we'll reduce the size. So how to reduce the size? Okay, let's see. Here we are using Node 20 version, backend and package.json, npm install and expose 80. Okay, everything okay. Now we'll see the multi-stage Dockerfile. That means we'll reduce the Dockerfile size. It's almost more than 1 GB, right? How we'll reduce the Dockerfile size? Let's see. Now the base image I am taking Node as usual. No changes regarding that base image, but we taken a image of slim version. Okay, observe slim version. Now the as usual work directory. See the image where we are taken that Node 20 slim version, not the entire version. Okay, that will reduce the image size. Let's check. Once we done, we will compare the image size. Now copy package.json. That is also good practice. Only we are copying our package.json only. That is also we discussed why only package.json. So here the npm stands for node package manager and the ca stands for clean install. Okay, so it only installs dependencies from the package log.json. So omit is equal dev flags install development dependencies only. Okay, development dependencies are packages you need for building, testing and development our application. So by using ---- om it is equal to dev, only production dependencies will be installed. So this reduces the size of our Docker image by skipping unnecessary development tools that are needed at runtime. Okay. To the npm cache, npm stores downloaded packages, metadata, and other files in a cache directory to speed up future installs. Instead of downloading the same packages repeatedly, npm checks its cache to see if it already has them. So clean means this command is used to remove everything in the npm cache. It's like clearing out a temporary folder on our computer to free up space and remove any unnecessary file. And ---- force normally npm will prevent us from cleaning the cache unless we specify tell it to do so. So that is why we are using ---- force also. And we know the copy command, right? And then expose. We are exposing at 8088 and remaining the same cmd part. Only we change the base image, we have taken that slim, and the run part. So delete the unnecessary files and download only project dependencies which is related to development only. So let's build this image. Build the docker file, we'll get a new image, right? Okay, we got an error. So something it's saying it's failed to solve docker file on the line 5. Okay, right. See, observe the error. We didn't give the space between copy. Okay, source location and destination. Right now it's okay. Now we'll build again. Okay, again we got an error. npm ca omit npm cache. Okay, let's solve this. So npm ca, instead of clean install, we'll give npm install. I think it might works. It's not taking the ci. Let's see. Now it's loading. Npm install works or not. Okay, it's working fine. It's copying. Okay, finish. We got a new image. So now see the image. Now we are given the name as opt, right? Now see the opt size and the front end image size, back end image size. In previous one we got a 1.18 GB. Now we are opt as a see 1.18 GB and 200 MB. So how much we reduced our image size? This is called optimizing, image optimization. Okay, this is the things we need to consider while working with the Docker images. And next we'll do the same thing with the front end part. Okay, the front end Docker image here. So we have a lot of instructions. We need to reduce this image size also. It is also more than 1 GB, right? So but this something different from the backend image. We have image called node in that, and let us do this. So first I'll keep as not capital as and build. So here I mentioned that node 20 version is only needed for build purpose, not entire procedure. Entire process, it works up to the building perspective, then after it won't works. Okay, that is why I given as build. Only for build purpose node is it works. And next see we have a lot of run commands here. We'll reduce that one also. That is not a good practice to give multiple run commands. npm install. Okay, npm run build. So here we'll give like ---- only for production dependencies it will download. Okay, so next apt update, apt install nginx -y, these kind of things we will remove that. So instead we will use the most reasonable thing that we'll take it as another image. So here we'll mention another image, nginx image will take, because while installing the nginx it will download entire nginx, but now only what is the build content. After build we'll get the dist folder, right? Only for serving the dist folder only we need nginx, other than that we don't need. So here now build code serve with the nginx image. So after npm run build we'll get a dist folder, right? So that purpose I am creating another image here. So from nginx I am taking nginx, that too I am taking a alpine image. So mostly we'll use alpine distroless images. So we need to aware of the difference between alpine image and distroless. I think the most difference is the shell level access. And then see, I've taken that image, not entire nginx software, right? So the default path is /var www.html. Is that correct path or not? Now let us check. So while working with the Docker images, all the images will be stored in where? Docker Hub. So we'll go to the Docker Hub and search for the nginx image. Let us see nginx image. Okay, we got a official image there. Check that image, and everything regarding that image will be given in this official document. So we'll see there the default path is user share nginx html, not var www.html. okay, now we need to copy the content into the user share nginx html, not var www.html. now we need to replace that var www.html into the user share nginx html. okay, now the whole content will be copy. Where to copy? The build is in the first stage, right? That is why it is multi-stage. The first stage we have the code ---- from, take the build code, ---- from is equal to build. In the first line we have mentioned as build. That means it takes the code from the first stage. The dist content it will take the from the first stage. The build is done in one stage and serving is in the second stage. That is what is a multi-stage Docker file. Okay, now simply I am copying same thing, but the change is default path. Why? Because we are using here image, nginx alpine image we are using. Now copy. So the dist file will be taken from the first build. App, it's not app, from the front end. In the front end we are having the dist folder. In that Angular the content is there. It should be copied in user share nginx html. okay, right, wq. now I will build this front end image. Docker build -t, it's an optimized one, right? pt-fr docker file location. Now it's building. Let us observe the previous image size and now optimized image size. So why it is needed, now we'll understand. Once it's done we'll understand. See the huge difference between those image size. Let us see. Once build done we'll see. So mostly we should not like images should be not be in a huge storage. Okay, Docker is for, it helps to optimize the images also. Let's see custom images, Docker images. Now see, so it came to 53 MB. See, previously it is more than 1 GB, now they are in MBs. See the drastic difference between the normal image and optimized image. Okay, so now I will remove the containers and I will create new containers with the optimized images. Let's check the application is working as fine as now. Now I'll stop the containers backend and front end. I already told you we can force stop also, but it's not a good practice. Stop the container and then remove the container. Okay, now the both containers are removed. Now I will check the application is down. Yes, it's down. Backend is down, front end is also down. Right, once again with the only IP it's not working. Let's back. Now Docker images, we have optimized images. Now we'll create a container with the optimized images. Docker run -dt -name. So we'll have the test backend, means BE, with the image called OPT. That is the backend optimized image, right? Now the same I will create front end also, test fr fe. Okay, OPT fr. So now I'm creating containers with the optimized images. Let's check how they are working. Now see Docker ps. So we didn't mention the ports, right? So that is why it's not exposing. We are not given ports. So that is the problem. So once again, Docker. I'll stop those both containers again. So port forwarding is most important one to expose our application into outside world. Okay, Docker rm. Now I will create the things with the port numbers. Same thing for the front end part. Test fr, the opt fr 8080, right? Okay, fr. So now check Docker ps and 3 containers are only running. So now check with the optimized images how it working. Okay, backend is fine, front end is also fine, right? So check add data something test. Yes, successful, submit. Yes, it's working fine, right? Even optimized images there is no change of work, but we reduce the image size. We can enter data, read everything. We can do this. Okay, right. Docker images. Now see the image size and containers. Alright, in today's video we have covered how Docker images work and the best practices for optimizing them to keep things lightweight and efficient. But there is more to Docker. In our next session we will dive into Docker Compose. It's a powerful tool that allows us to manage multi-container. So we will learn how to define and run these 3 containers with just a single command. So if you are ready to take our Docker skills to the next level, make sure to hit the subscribe button and stay tuned for the next session. Catch you then.